Oh, it's way up there. You don't see that? Sorry, people who are watching this. I'm just going to keep it down below this dot. Okay, so letter A. Now let me check it. Sorry, this is me. There, now that's visible. Okay, so the letter A is basically like it's suppose A is just a simple proposition, right? So this is just A. It's Al is here, or the apple is yummy, something like that. Okay. The case is that statement can be either true or false, right? And all a truth table does is it takes and it looks at every possible truth value for that statement. That statement can be true or false. What happens is it then says, well, what if that, instead of saying A, said bar A? And what it would then say is, if A is true, then what would bar be? It would be false. Because if a statement A is true, then the opposite of it is false, because it's negating it, right? Same thing as, anytime A is false, the other one's true. There's an old joke about philosophers that, how do you keep a philosopher busy all day? And it says it's something like, you give them a card that says like the statement on the other side of this card is false, and they flip it over and it says the statement on the other side of this card is true, and they flip it over and they say the statement on the other side of this card. So that's a logical contradiction. If statement A is false, if that is true, then then that statement is false. And so it's a little joke about it. Okay, it's not a funny joke, but it's a little bit of a joke. Okay, so that's kind of one way to keep a philosopher occupied, is they would actually find this. And actually, philosophers will discuss this, and I actually discussed it for 30 seconds already, which just shows you, and I'm trying to be nice because I realize none of you are philosophers, and keep the talk to a minimum. So that's basically how it works, is a truth table just looks like this. If A is true and A is false, if it's true, then it's false with the bar, and the bar would be true when it's false. Is that fair enough?
You just say it so fast.
And then I'm going to misspeak because I'm talking too fast. Does that make sense what I'm saying
Yes,
here?
so that's invalid.
No, it's not. This isn't valid or invalid. This is just, if A is true, anytime A is true, bar A would be false. Anytime A is false, bar A is true. Does that make sense? So basically what it's saying is if A has a truth value of true, then bar A will have a truth value of false. Does that make sense? Mm-hmm. And so this table is saying that here on this first line. On the second line, it's saying if A's truth value is false, then its truth value in bar A is true. Is that good enough? All right. So I went to get these overheads. I said, do we have any overheads in the department? And they said, I don't know. Nobody's asked for that since 1989. And that can't be, because I was teaching in like 2000 and we still used overhead projectors. Anyway, but they said...
Michael Ram uses them. I think I remember him in chemistry.
Okay, so I'll feel better that Michael Ram uses them. Hey, he's master teacher, so he's I can turn to that. No, I mean I like the overhead. I think they use it more in sciences and math because you're doing problems and it makes sense. And it does. I forgot about the blinding effect of it. Anyway, that's great. Anyway, so basically, then the next would be suppose you have a statement like A plus B. Well, if you do this, you have two statements, and so what you're going to do is you're going to want to see what are all the possible truth values that this statement could be. If A is true and B is true, is it true? If A is true and B is false, is it true? If B is false and A is true, is it, that kind of thing. Like, when is it true and when is it false, right? And the way we do this is we take two, we're going to need so many lines to do it. It's like, if you have a green shirt, this is my shirt, and a red shirt, right? And you have, does those look anything like shirts? Just say yes.
Yes.
Right? Control your grades. Anyway, and then suppose you had, blue shorts, or red shorts, sorry. Blue shorts, yes, they look horrible, and green shorts. And suppose you said, how many pairs of outfits, how many combinations could I have? Now, if my girlfriend was here, she'd be like, who the hell wears a green shirt with, or blue shorts with a red shirt? Or something? She'd tell me these don't match. But I say they all match, because red and green is Christmas. Green and red, Anyway, and so, but the case though is you're kind of like, how many different combinations do I have, right? Well, this is the same thing. How many different combinations do I have if I have A plus B? How many different combinations of truth values do I have? And the answer is 4, right? Feith says 4. And the reason is because A can be true while B is false, and A can be true while B is true. And A can be false while B is true or false. So there's 4 different options. The way we can do this is we can take 2 to the power of n is sort of the rule. And n equals the number of letters there are. So unique letters. So if you have A repeated, you only count it once. But if you have A plus B plus A, like that, then that's 2 unique letters. And so n equals 2. So 2 to the power of 2 is 4. But if this was A plus B plus C, then you have 3 letters. N becomes 3. 2 to the power of 3 is 2 times 2 times 2, which is 8. Okay? And then when you get really fun, you get like 8 different letters. And 2 to the power of 8 is, go ahead, 4, 8, 16, 32, 64, 108, 256, right? And you will need like 6 sheets of paper to do these problems. And that's when it gets to be fun, right? Because all this up till now has not been fun. It's not until you want to, put a hot poker through your eye. Maybe some of you are already there. Anyway, regardless, the point is, let's see. They said to me, I said, I don't know if I'll be able to erase with these Sharpies or whatever, these dry erase things on this. I don't know if that'll work or not. And they said, Tim, nobody's gotten a overhead sheet in like 17 years. You can just throw them away when you're done.
Oh my gosh.
I asked if they would reorder them because there's like 1,000 of them there. And I said, what if I run through 1,000 of them? And they said, no, we will not reorder them. I'll have to buy them on my own then. So anyway, so maybe in about 20 years, if I'm still doing this, I'll have to go buy some of these. Anyway, so if A can be true, false, and B can be, so basically we have to fill this out. The best thing to do is just start off, I think the book, does it start off true, false?
Yes.
Okay.
True, false.
So here's the deal. A can be true, false, and B is true, false. Usually what you do is you figure out the number of lines you need. You need 4 lines. So usually what I do is I start off and I go true, false, until you're done, right? So if it was 8, it'd be true, false. So that'd be 8, that's 8 lines. The next time you double the number of T's, so you do 2 true, false. And then if you did have a 4th or a 3rd letter, it would be true, false. I think I missed a true in there, but it'd be, so basically every time you double it. So if you had a letter like plus C here, you'd have true, and then false. I don't have enough room, but that would be the way it would go, right? We don't have that, so it's a moot point. But the reason is that shows every possible combination, just like with our shirts and pants, right? I have told you that 2 times 3 is 6. There are 6 possible variations of how you can look really great with red shorts and green shirts, right? I think it works. Does that really not match?
It depends.
Maybe like throw a yellow hat on if you're on safari.
Right.
Okay, see?
Yeah, you gotta do something out there for that.
Uh-huh.
Yeah.
I don't know. I think that you guys are wrong, but anyway. Anyway, so what happens though is if A is true and B is true, then what the truth table does is it says, what is it if they're both true? Well, this is a statement like if I say A says something like Alan is here and B is something like Betty is here, right? So Alan is here and Betty is here, right? We know it's true that Alan's here. We know it's true that Betty is here. Or we could use your name if we want to, it's true that Gracie is here. It's true that Heath is here, that kind of thing. Then we could say, if I say it's true that Gracie is here, it's true that Heath is here, then if I have two true statements and I combine them, I conjunct them into a statement that's, Gracie and Heath are here, then it's a true statement, right? It's not valid, it's just true. We don't want to say valid because valid is an argument assessment, right?
Okay, yes.
And then suppose, though, on the other hand, Gracie has walked out in disgust at this point, right? And so Gracie is no longer here. It's false that Gracie is here, but Heath is still here, right? So if that's the case, then is that a true statement? They say Gracie and Heath are here. No, it's false because Gracie left, right? And so that makes that false. Now what happens is if Gracie comes back and Heath leaves now in disgust, I don't know why, but then that becomes false. And if they're both not here and I say Gracie and Heath are here and both of them are not, then that's a false statement, right? So what you find is the only time A and B will be true is if both A and B, if both the conjuncts is what we call them, are true. If both the conjuncts are true, then it's a true statement. Is that fair enough? Yes, Danielle.
But doesn't it mean that they're both there because there's no negative in front, like no bar in front of either?
Well, this is a statement. This is just a general statement, like any statement. This is assessing the truth or the falsity of it. It's just a statement like, Gracie and Heath will be here tomorrow. Now, I'm not going to be here tomorrow, so I don't know why you guys are going to be here. But Gracie and Heath will be here tomorrow, right? That's the statement, right? Now, the case is I don't know if that's true or not. We won't know that's true or not until tomorrow when they're either here or not. And so what it's saying is if tomorrow it ends up A is true and B is true, then the combination is true. But, it's like anything. I could be making a false statement. If I'm making a statement in which A is false and B is true, but I say A and B is true, no, it's not. It's false. Does that make sense?
Yeah.
So A and B, we don't just assume A and B is true. We're assessing in what circumstances A and B would be true. Every possible situation, right? I like to consider every line as like a possibility of the truth value or a possible world. Sometimes I'll say in my classes, I'll talk about possible world. Like this is one of the possible worlds, and my students always roll their eyes like, what the hell is this guy talking about? What's he been smoking? And the answer is nothing. I'm just mainlining happiness, right? And the prescription drugs my doctors give me. Anyway, I go around ER to ER. It works well. Anyway, joking. My cousin who's an ER doctor, he just writes them for
I'm a
me.
nurse, I can teach you.
Oh, good. Thank you. You can just take the IV out, suck a little bit down from that morphine drip. Yeah. Anyway, God bless the cancer ward. Anyway, what's that?
Wouldn't put it past somebody.
Well, actually, that's why they lock them. That's why the IV bags are in, like, the CRNA has to come in and lock it or whatever, because nurses will come in and, like, there have been cases, or doctors, or
Oh, yeah.
whoever the junkie is, or janitors, whatever, right?
Yeah, it's usually healthcare professionals, really.
Yeah. I mean, it would be somebody coming in the hospital. Anyway, so then the next would be A, wedge, B. So there's two different letters. How many lines are we going to need? 2 letters.
Is that 4?
4, you're right, Gracie. Good job.
The 2 in.
What's that? Yeah, it's 2n. So it's 2 to the power of 2.
Represents how many lines?
Yes. The number of unique letters is the number of lines you need. Now, what I say is because the book does it this way, since you need 4 lines, you're going to start off with, let me use a different color here. You're going to start off with true, false, sorry. If you have to correct a T or F, make sure to be careful about that because they can look a lot alike. A lot of times I'll have people who do this on the test, and I'm like, Is that supposed to be a T or an F? I don't know. Zero.